Welcome back to Repair University. Now, we've been talking lately in a few episodes about kind of this onslaught of aluminum and what it takes to fix the cars and estimate the cars. So we thought it was time to get to actually repairing a panel and talking about the repair considerations and actual methodologies for repairing aluminum. Larry, we're going to actually do something on a panel today.
Yeah, we're gonna try and mock up a little bit. I did some stuff inside the shop. I can't do too much stuff inside this area of the shop, but we have it mocked up enough that we can actually show what some of the process would be. You know, I can't teach it in a 15-minute video. It really works the best is when you do a hands-on program, which runs about 3.5, 4 hours we're looking to do. We've done like 5 or 6 of them for a couple of the auto body associations in the Northeast. It's worked out really well. We've been asked back a bunch of times to help out, you know, the technicians learn how to actually repair these aluminum panels.
All right, well, let's get to it today. I kind of want to make sure we cover a little bit of the basics and some of the principles and make sure that we're just giving just enough information to give everybody kind of a small knowledge base to go off and get the best training that they need from here.
Sure. Well, this particular piece of equipment here is a Weilander Schill one, and there's probably 12 different, you know, dent removal, well-done pins that are available out there, different type equipment, and not much different than your steel type product. You actually have a pin that you would push in, and the pin needs to sit on the inside here, but it will sit a little bit higher than it would on a steel version where it's going to push all the way in. There's a little nipple at the very end of it that actually welds on. And these are good for one-time shot only. This isn't plugged in, but you would have to clean the area, and based on the equipment you're using, they usually have 2 grounding clamps that have to be put on, a work clamps. And in this case, you would aim your spot where you want, but as soon as you touch it, it's going to weld. So you got to be real careful on how you do this. So you line it up, you get it down, and then you would push, and boom, it's going to make one sound, and that's it. And then you pull this off, and you'll wind up with a pin sitting on here. There was actually a hole blown over here that we purposely did the wrong way to show what could happen, because now this panel's ruined. Well, there's 2 schools of thought for this. The old-fashioned way of sanding open the panel, welding on the pins, and starting to pull off of them. Well, with aluminum, you can't do that. You have to heat it. And you generally will need 2 people to do this, because as I show you the setup, you're going to see I'm going to have you move around over here afterwards, but I'm going to show you that you actually need 4 hands. It's not like a steel panel you can play around with. There's a lot of stuff that has to go on, and we also have to know the heating. Normally in my class, what I'll do is I'll get some of these panels, and we'll make a dent there. Now that's a fairly large dent that I just put there. Another school of thought is to heat it first and try and remove it without any pins being welded on there. And you'll be very surprised if you start heating up this aluminum panel, how fast it's going to move. Now you can have a non-contact thermometer at the same time, keep giving the heat, and you'll start to learn the paint really won't blister that bad, and it's really not going to turn a lot of color. You keep the temperature low, and you have to move it around. Now, some people talk about induction heaters. The problem with induction heaters, we can't get a small enough tip on an induction heater to really get into the center of this and work your way out and back in again. This is a standard torch head, but Weilander Schill for the Benz program puts out about 5 or 6 different torch heads for the propane gas. Now you have propane, this is a MAP gas on this one. You have propane gas, which is the one I usually teach guys to start with. MAP gas runs a little hotter, so we use that next once you start getting some skills on some damaged hoods. And to be really, really good, you use a much smaller torch head and you use it on a regular oxyacetylene tank. But you got to be real careful, and obviously welding tanks inside a shop probably isn't the best idea anymore. So you're probably better off with a MAP gas or a propane gas. Start with propane, move your way up to MAP. But if we go ahead and I just bring this torch out and I start in the middle,
oh, wow.
and I move
it's already
out,
raised, yeah.
and look at how fast that moves up. And
yeah.
You can let this go as many times as you want, but the problem is it cools back off again. What you're going to wind up with is you're going to wind up with an issue where you'll still have some of the dent there. And it'll start to cool off. And now, once again, aluminum moves very, very quickly. Okay, this is still warm. You can see my hand, but a lot of it, you know, you can see came out.
Right.
And I could do this maybe 15 to 30 times, get a lot of it out, and then normally what I'll do is I'll sand over the top with 80 grit sandpaper, or even sometimes a file. Not even get down to bare aluminum, just stay with the paint, and you start to feel, and you're like, this needs a tight wipe of putty. Well, if I heat it a few more times and sand it, I could probably get a lot of that ding out and put just a tight wipe of polyester putty and have less material on the hood. Now, once again, this is a small little ding I made. You'll still see there's still a dent there.
Yeah.
It's going to take a lot of time to get this out. It doesn't happen very quickly, but as you saw, the aluminum moves very, very fast. It rises very quickly. Okay, and you notice I put flame on the paint, and I really didn't. You know, the paint's just barely turning color. Now I know from practice numerous times that that's, you know, way below the temperature grade of 470 degrees. And you'll see that's probably about 220, 225 has been the average that I've seen, because I've done this class with a non-contact thermometer. But let's say that doesn't, you know, totally take out the ding. Okay, so now we want to weld the pin on. So let's say I first heated this area. Now I'm going to weld my pins on there. Since I have my pins on there, what they give you, unlike the slap hammers that we have with steel, or the star that with the slide hammer already attached to it, everything's got to be softer and easier. So they have these little screw-on eyes that'll go down, and I mean, you just screw them on nice and easy. And you try and get them all in the same direction you want them to be in. You screw these down. Then what we're going to do is get these lined up. And then we have a lever. Now the lever you have to be careful with, because I've seen guys in class actually put this fulcrum in the wrong spot and put it down where it was. So you got to kind of test it. It does have a rubber foot to it. You want to keep an eye on where exactly it is at all times. So you slide this bar in there, and I'm going to just slide this in here in this fashion. And then you give a little tight, just a little tug to it, and say to yourself, okay, that's not going to be good. I'll hold this here, and I'll bring this out a little bit. Now I realize that's not enough pressure, so I'll bring it back. Now I say to myself, I think that's going to be good there. Now that I have that in a spot there, I have this. Now what do I have to do? I said before, I got to heat it, right? Well, if I heat it with the torch, how do I hold the non-contact thermometer?
So here comes the second.
Now, also, while I'm holding pressure on this, and once again, this would normally be on the car, so this is going to move all over the place if I pull on it, but if it's on the car and it's being held shut by the, you know, the hinges and the hood lock, as I'm pulling on this and I got tension, I'm going to feel as I heat it, it's going to lift easily. You don't put pressure, you just hold it there, and you'll feel it come up. Well, as I do that, I'm going to need to lightly put some pressure around the area here to kind of keep the high areas, you know, down a little bit and raise the low areas. And it's very, I mean, it's really light pressure, because remember, you're hitting on something that's hot. Well, how do I hold the torch, hold the non-contact thermometer, and hold this? So, I'd like you to come around the back here, if you can, for a second. You can take the torch, you just squeeze the red trigger.
Okay.
And now when you use the torch, give me that for a second. When you use the torch, you want to keep in the area close to where it is, but you move back and forth. Remember, aluminum will never change color. So that's another issue that we have. If you sit there and wait for it to turn red, at one particular point in time, you're going to see it kind of wave, and then it's just going to disappear. So you want to just keep it going a little bit, back and forth, nice and easy, and try and get the outside. So we're just going to mock this up a little bit. I'm going to hold pressure here.
Okay.
You go ahead and squeeze the trigger and put your hand in there and get it close in, back and forth. You're not going to do anything wrong. And I'm going to put pressure. At a certain point, come around the other side. You're going to go back and forth, and I'm going to feel this move up a little bit for me. Okay, then you can stop. Now what I'm going to do is hold the pressure. And I'm going to go back and forth. And once again, I'm mocking this up. We're not really fixing this thing. And then when I'm done, I'll put this stuff off to the side. Now, here's the other trick that everyone has to realize. One is, don't grab these right away, because you just heated up the panel. It's aluminum. Aluminum travels onto these stainless steel pins, and these things can be very hot. If you grab it very quickly, try it. It's hot, okay? So until you get used to these things, to realize you could just grab this tight and burn yourself very badly, because it doesn't look like it's hot, you know, because you don't realize how much that aluminum transfer goes. Most shop technicians have been trained on steel cars to take these, grab it with a pair of vice grips, and twist back and forth. You'll make a hole. What you have to do with these is take a pair of diagonal cutters, clip them down as low as you can, and file, not grind. File across the top to get them level, and they actually become almost part of the repair process, or get sanded off almost all the way later on. So this is a quick, small little thing of what we're trying to show how to do here, because it would take me a very long time to do it in a video. And you know, it works better hands-on. I could show all the video I want, but hands-on, working with the text, where just exactly what you just did now. I'd show you how to do that. I'd make this big dent over here. We'd try and repair most of this. And you would actually try and do it yourself. And that's the idea we're trying to do, is get the technicians comfortable with this type of equipment, with this type of process, and realizing what they have to do to try and remove these dents. And then you can figure out what is repairable and what's not.
And so just like with a normal stud gun procedure, when I'm done with all of my exterior, getting my studs off, I've got some corrosion protection, some issues to take care of on the back.
Well, you'll have some corrosion protection between contact corrosion and stuff like that will get on there. But with aluminum, unlike steel, you don't need acid etch primer or wash primer to get in there and etch the metal. You're just putting epoxy primer, front and back side, so you got to make sure you get to the backside area of the panel. We took off the hood insulator and made sure we were running the area of foam over here that we were doing some of this repair to. And this is pretty much like the hoods I would tell people to keep. It's damaged over here, it's no good to use. Keep it, I'll make dents around on there. There's times I'll drop a ball, there's times I'll put a piece of wood on there and hit it with a hammer to try and duplicate a line dent. Which you'd be surprised, aluminum's not that easy to dent in many cases, but we'll try and make the dents and try and show people how we would repair them. Some of the stuff's not feasible to repair that we're showing you, but we show you a process that if you wanted to do it. And then afterwards, we would check this with dye penetrant. And sometimes I'll even try and make cracks in the material. Like I won't even heat it up, I'll just pull it like a slap hammer type of thing to try and make a crack to say this is why we just don't walk over and slap hammer dents out on the aluminum panels.
Let's talk a little bit about the dye penetrant, because I think that's somebody that a technician or even an adjuster who hasn't seen that process or been around a lot of aluminum isn't really familiar with. But even going down into the aluminum structure panels, that's a really important step post-repair. When you think you're done, maybe a little extra step there.
Well, pre-repair, damage analysis, or even post-repair on repairs. Some manufacturers require after you're done welding, you have to check your own welds with dye penetrant. It's a welding, it's sold at most of the welding supply places. Companies like Reliable, who sell this particular piece of equipment, also sell that material too. It's a three-part product. One's basically a cleaner. For good terminology for us, I guess like a wax and grease remover. It cleans the bare aluminum area. After that, you would spray on this red, looks like candy apple red spray paint in a way. It's kind of see-through. It stays on for just a few minutes. You follow the can's directions. And then you have, you wipe it off. And you use that same stuff that you use to wax and grease remove the area. You spray that on and wipe it off. Now, you should really see nothing but the aluminum again. And then you spray this developer on, which looks like a white powdery type substance. You spray that on. And then if you see red encrest into areas or in crevices, there's cracks there, stress cracks. It's basically not to show you what you can see with your naked eye, it's what you can't see with the naked eye that it's trying to show you, oh, there's stress cracks. And I've actually gotten like big, huge starbursts of cracking when I try to repair a panel improperly to show what could possibly happen, which means that panel could fail later on. It's an issue with an outer body panel, but with a structural part, you have that splintering of red in there. That means either the weld's no good or there's a crack on the structure itself, and that can be a major issue later on, not just for drivability and durability on the roadway, but in a subsequent collision event.
That's a lot of great information to share, Larry. Thanks for that quick repair little demo on aluminum. As you can see, repairing aluminum isn't that big, great bear that we all seem to be worried about, but it does take a few extra simple steps and a few extra precautions and a little bit of practice to get it down right. There's a lot of tools and equipment out there by different manufacturers, but at the bottom line, you're gonna have to spend some time practicing and working on the panels to make sure that you get your technique and your procedures down correctly. And for you estimators, it's a good thing to watch, to start thinking about the time that it takes to do different things and maybe some additional procedures and things in your estimate that are gonna be required. Stay tuned for more episodes of Repair University, where we're going to dive deeper into repair technologies and to the estimating. Thanks.